So today we're going to find the slope of a line in a graph. So when we find the slope we need to remember the vocabulary. The ratio of the rise, or the vertical change, to the run, horizontal change, between any two parts of a non-vertical line. So these are definitions that you need to make sure you're writing down in your notes. Slope. Go ahead and take a minute to pause and write the definition. So slope is just really telling us how steep a line is. Slope is equal to the change in y over the change in x. And the way that we can write this mathematically is with this lovely little triangle. Change in y over the change of x. So let's get started on a few examples. So the thing I want you to really remember when studying slope is rise over run. So change in y over change of x, you really need to remember the slope is the rise over the run. So what we do is we find any 2 points on a line, and of course it's a very good idea to find points that are easy to read at nice coordinates. So in this case they picked 1 and 2, and then the next point is 5 and 4. So when we look at this, we just count up to the rise and then over the run. So we have 1, 2 is the rise because we're now level with our next point. So the rise is 2 over our run, so we put that of course as a fraction, which in this case is 4. 1, 2, 3, 4. So our slope is 2/4. Another word for that is, 1/2. In our next example, we can do the same thing. We can find any 2 points and we can count. So in this case, we have a rise of 1, 2, 3, but we're not going up. We're actually going down. And remember yesterday when we talked about identifying a positive graph or a negative graph? When we have a graph that's facing this way, we know it's going to be negative. So that's a pretty big indicator and a nice little hint for us. So we have our slope, which is our rise, or in this case our fall, over the run, which is -3 over our run, which is 1, 2, 3. And notice how we're going to the positive side. We're going towards the positive side, so that's a +3. We're going to our negatives here and to our positives here. So we have -3 over -3 or -1. Now I want you to try example 1 in your notes. See if you can calculate the rise over the run. Looking at these 2 examples, to find the slope of the line, we can count the rise over run. So in our first problem, problem A, we have 1, 2, 3, and it's positive because it's going up towards the y, positive side. So our rise is 3. Let me darken that color. And our run, or our x, is 1, 2. And it's going toward the positive side, not towards the negative side. So that would give us 3/2. And you can leave it in improper fraction form in the case of slope. In our next example, we have a rise, which is our y. We can see it's -1 because we start here and we go down 1, so negative 1, over our run, 1, 2, which is positive 2, or negative 1/2. And remember, this is just like our division rules. Negative 1 over positive 2 is the same as negative 1/2. If we had a negative on the top and a negative on the bottom, which we don't in this case, but if we did, then it would be positive 1/2 because a negative divided by a negative is a positive. But in this case, a negative divided by a positive, remember our division rules, is a negative. Now let's look at another example. So we have this word problem that says volcanoes. The graph represents the average distance traveled by a lava flow over time. To find the speed of the lava, find the slope of the line. So the first step in creating this problem and solving this problem is to write the definition of slope. Slope equals the rise over the run, or the change in y over the change in x. So the first step, we can just choose any 2 points. So we have 4 and 6, and then again, choose a point that goes through a line at a very easy place to intersect. So we have here. So we have our rise, 1, 2, 3. So we have 3. Over our run, 1, 2, to get to this next point. 3/2. And before I go on, I want to actually show you that really it doesn't matter what point. So we have this 0, 0 at the bottom here. And if I were to use this point and the point 4 and 6, I can also do the same. If I have a rise here, that's a rise of 6. And my run here would be 1, 2, 3, 4. 6/4. And notice that 3/2 and 6/4 are equal. So we need to find the slope of the line. In this case, we need to find the unit rate, because we have to find the meters per second. So we can just divide, which would give us 1.5 meters per second. And of course, we would get that by dividing 3/2 by 2 to get a total over 1. And that would have worked as well with 6/4. We would, of course, just divided both sides by 4, and it would have given us the same, 1.5 over 1. So the speed of the lava flow is 1 5/10 meters per second. Looking at example 2 in your notes, I now want you to read the word problem, and I want you to calculate the slope. Lemonade stand. The graph represents the cups of lemonade sold over time. To find the rate of sales, find the slope of the line. So again, our slope is our rise over run. And if you want, you can just start at 0, 0 and end at 2, 8. Go ahead and take a minute. You can press pause at any time. So in this case, we have a rise of 8 and a run of 2. So then we need to find the unit rate, which of course means that we need our denominator to be 1. Well, if we divide both sides by 2, we can get that, which would give us 4 over 1. So the lemonade's sold at a rate of 4 cups per hour. Now let's look at some more examples. I want you to try this problem where it says plot the points 3, 4, and 6, 3. Remember, 3 is your x, 4 is your y, and in this case it's the same, x and y. Then find the slope of the line that passes through the points. So now that you've plotted 3, 4, and 6, 3, now we can find the slope. So a good idea, of course, is to put an arrow, a straight line, through, and to look at if the line is positive or negative. Now remember, we use some tools to see if a graph was positive or negative. I should have probably switched these, but if a graph points this way or to the right, the top arrow points to the right, that means that it's positive. If it points the opposite way, or the arrow points to the left, it is negative. So I know that this is a negative graph. My slope should be negative. So we have a rise. So let's look at our rise. We have a rise of 1. Notice how we're going down to connect the dots. So that would be negative 1. Because, again, kind of look at an arrow. If we're going down, that means that we're going towards the negatives. So we have negative 1, and we have a run of 1, 2, 3. And this is positive. Remember, we're going to the positive side. So when we have negative 1/3, that's our answer. That's our slope. Now, what if in example 2, suppose a similar graph represents a different lava flow at the line passes through 3, 6. Find the speed of the lava flow. So if we look back at our graph, we can look at point 3 and 6. So if the line passed through there instead, we would have a different line. And then we can check our rise over our run. If we started at 0, 0, our rise would be 6, but now our run would be 1, 2, 3. So our rise is still 6, over 3. Or 2 over 1, which is 2 meters per second. Now for our final example, we're going to draw a line. We're going to use slope to draw a line. Draw a line that has a slope of -3 that passes through point 2, 5. So first step, of course, we're going to plot 2 and 5. Then we write the slope as a ratio. Well, we have a slope of -3, which of course any fraction we can write -3 over 1. Now we know that one of the numbers is going to be positive and one of them is going to be negative, but we don't know which is which. So after starting at 0.25, we can go -3, 1, 2, 3, and a run of +1, which would mean my second point is plotted at 3, -2. Or 3, +2, sorry. So we have plot the point 3, 2. Then our step 4, of course, is to draw a line. So you can use a ruler to draw a line, or the edge of your textbook always makes a lovely straight line tool. In this next example, I want you to try to draw a line that has a slope of 1/3 and passes through the point -1, -3. You can pause the tutorial right now. So now we can look at this together. So let me draw my graph to the best of my ability. So I'm going to use some graph paper to draw my graph. So here's my y, here's my x, And now I can plot points. So it runs through -1, -3. So we have -3 here. So I've taken a moment to draw a few more lines through my graph. So our first line, our first plot is -1, -3. Again, -1 is our x, -3 is our y. So my first plot is here in the red. Then we have a slope of 1/3, which means that 1 is my x and 3 is my y. So my slope is 1/3. So my change in y over my change in x. My rise is going to be 1, +1, so I'm going up. My run is going to be 3, and again it's positive, so I have 1, 2, and 3. So I can just plot my next line here, and if you want to keep doing that, you can. I can go up again, rise of 1 over 1, 2, 3, and plot a third point if I like, to make it a little easier to connect the dots. In fact, I think I might even do it one more time. 1, 1, 2, 3. So I can see that I go through the point 8, 0. So now I can use my ruler to draw a straight line. My ruler tool doesn't work as well on the iPad, but you get the idea, connecting the dots through a straight line. And now I have drawn a straight line using the slope. So now I want you to try example 3 in your own notes, and I want you to draw a line that has a slope of -2/3 and passes through the point 5, 4. So that, of course, is the third guided practice at the bottom of your notes. And if you have any questions, you can feel free to email me or ask any questions along this lesson. So going back to our goal was to find the slope of the line. Make sure you understand properly how to find the slope of the line and how to use that slope in various types of problems. When remembering slope, the thing to remember is rise over run. Slope is always rise over run. Good luck!